That's a very good reason to rewrite. When you can tell, when you can say, well, if we don't rewrite, it won't work. So, Johan, you know expression, never go back to an unexploded bomb. It's a little bit different it's not a correct translation, but I think the meaning is well enough, you know.
Yeah.
So what about source code?
When I started programming, I had this this saying that if it ain't broke, don't fix it. But you know that at some point someone is going back, and if your code is messy and hard to read, my experience is that then there is probably something wrong with it that you haven't actually taken the time to consider. It might be that there's a calculation that is kind of wacky, but you got it working for the cases that you test, but there are the cases that you haven't tested. And since your code is hard to read, it doesn't work for those cases. And you realize that a month later. And when you get back a month later to update the code for those fixes, it will take you twice as long to figure out what the heck you did with that code.
First of all, the point here is that it's the relevance of this discussion is for IT system that develops over time.
Yeah.
Static things that you've done with, you know, just leave it. And I think that one of the anecdotes in the IT business is that the old IBM, I think it was called VM 370 operating system for mainframe, is the most difficult thing to be allowed to make changes to ever, because it works and they don't want it. They don't want it
It's
fixed.
dangerous to fix.
Yes, it's dangerous to fix. Maybe because the code is lousy. That could actually be the reason to them not wanting to do anything. But I've been working on systems, various systems during the years, over the years, you know, and one of them, some of them actually, have had a lifespan of 20 years or something like that. But it seems that it evolves in new direction, and very rarely, you know, you actually go back to some functionality you did some 10 years ago. You just go on working, and it works until they don't use it anymore. Then you just scrap the whole thing, you know. And in the meantime, you get new habits, maybe some better habits, you know, when you're coding. So when do you really get the opportunity to go back to the code and refactor it? That's also a question, I think, because unless it's your own program, you know, somebody has to pay for it, and the customer would ask, what value do I get from this? And we can argue, you know, a lot of arguments like it will be easier for somebody else to maintain it, and the longevity of the project will be better, and blah blah blah. But when it comes to getting pocket out of the money here now, you know, those arguments tends not to be very strong.
No, but perhaps we should be better at coming up with arguments for actually using some additional time to make sure the code is well written and easy to understand. Because I've been in projects where I ran into some old code that I've written, and I realized that in order to actually implement the new updates into the existing code, I had to basically rewrite the entire code to be able to make everything work as intended.
Ouch.
Yeah. And I'm not sure if of course, if I've written it that way with that intention from the beginning, it would have been um, easy to rewrite. But when when we did the spec for the first piece of the code, no one thought that we should use it in a different way later on. I think it had something to do with uh, we we managed time by specific time intervals. So we had like a table for or an entry for every hour, but then some customer wanted half hours, so then we had to kind of rewrite it to make use of timestamps and create a new table that actually contained start and stop time for the bookings instead of just an hour
Mm.
timestamp. But there were so many other features in this. For instance, validation. If this customer is allowed to use this booking on this gate for this hour, so there were so many things that details that were we needed to rewrite in order to get the change to work. So it was really complicated.
But then that's a very good reason to rewrite. When you can tell, when you can say, well, if we don't rewrite, it won't work. You know,
No, no, no.
I can't think of any better reason actually. But sometime when you look at your work of art, I'm talking about software. I could do this better, you know.
You mean your
And
dirty
you think,
underwear?
yes, well, that's not that's your code, not mine. That's
Okay. Yeah,
everybody
yeah,
else's code is dirty underwear.
yeah, yeah,
Laundering dirty underwear um, and looking at other people's source code is very similar actually.
yeah.
But you might actually think, okay, I could do this better, or I could do it in a neater way. And then, well, the problem here is that, well, most of the customer relationships we have, they don't think of it as art. They think of it as software they need, you know, and they don't really care how it
No.
looks because they never see it. So um, should you change it? And then there's another aspect I could say is that when you have this project that's been running for a very long time, then the reasons for refactoring might actually be larger because, I mean, you're going to work for it for a substantial time yet. But as it is now, I mean, the lifespan of a DOS application was huge. The lifetime of a Windows application was, well, as I see it, around half. And the lifespan of web application is, again, about half of that of Windows application. And the lifespan gets shorter and shorter and shorter because the various techniques and the various ways that we can develop software evolves all the time
Yeah.
and very fast.
Mhm.
And nobody wants to sit with the software development tool of last century. I mean, we
So
want to be on the
you
edge.
mean that's in the future we will rewrite all the systems and all the code once a year just to have an updated and fresh system that can do everything?
Well, I don't know if it's once a year, but I would certainly think that it would be more frequent than we have now. Also because with the involvement of the web technology,
Yeah.
I mean, it started in the beginning of, it really started with the World Wide Web in the beginning of the 90s, but it has not been until within the last maybe 10 years or so, it really moved, you know, until you're actually having web applications instead of just
Yeah.
HTML pages.
But then I have another forecast for you.
Mm.
And that is, if you are going to rewrite the code for systems that often, you will not rewrite all the code, because you might change the front end framework, or you might change the database, or you might do something with the code in the middle. But what will happen is that you will have legacy JavaScripts lying around that you don't uh, change because it didn't work in the new framework that you switched to. So you keep those, and then you really get a mess of all kinds of different JavaScript frameworks and backend frameworks, and I don't know what, um, that you don't want to deal with. So you can really mess up a system by doing that.
Hmm. Yeah, well,
Because
I noticed that when you talk about JavaScript framework,
yeah,
every time you get a new framework and everybody says, this is the framework,
yeah, this is the
it's
best one.
obsolete within half a year, something like that, and then there's a new one.
Yeah. So yes, it's nice to have this framework because it's easy to just plug and play things and get things up and running. But God, was a mess you can create when you start to switch between them, or and you don't want to rewrite the entire application because that's going to cost you a lot of money.
Hmm.
So if you pick a
Oh,
framework, then stick with it. But
okay. Well,
you
like
can't even
Dataflex.
do that. Yeah, yeah, Dataflex you could stick with because that
Yeah.
hasn't that still works the same way as it's been doing for
Well, you got
many
a
years.
40 years backward compatibility
Yeah,
of the newest
more or less,
version.
yes.
Yeah.
But the thing is, in this JavaScript framework, what tend to happen is also that every year they come with a new version, and some of the times the new version doesn't even work with the old version. So you still have to rewrite the code in order to have the latest version of the system.
What happens sometimes is also that um, you need a fix to something, and you don't have all the time in the world. So you go into your source code and then you make a hack of some kind, um, and you might think I should do this problem one day, or maybe you just think, what the heck, it's a hack. Um, but then again, some source code files, tend to be cluttered up with hacks at one time. But when you look at your own source code, then
Yeah.
Maybe it should teach you to develop some empathy and forgiveness towards other programmers and their source code, maybe.
Yeah. Uh, I'm at the moment now where I'm more thinking about how I should try to educate developers on how to write better code. What should I say to kind of give them the understanding of code the way I've gotten through my experience? I've written a blog post about my history as a developer, which
Mhm.
steps I went through in being more and more uh, apt to writing clean code, all the way from my first game I made, basically, where I didn't even know that arrays existed. So I wrote, I think, 150 variables.
Fantastic.
Yeah,
Yeah.
but it worked. But it would have been a lot less code if I used arrays instead.
Yes, but it's also a question of using functions and procedure where it makes sense,
Yeah,
but don't use it when it doesn't make sense. And write things understandable somehow,
yeah,
and then make some clean, nice code. I mean, that's an artisan discipline. I remember the first small IT project that I had in university. we were coding on punch cards. And every time we ran the program, it was on a big IBM mainframe. You put the punch card in a punch card reader, and it says da 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 da, and then it printed out the source code every time, and then the result in the end.
Okay.
So our deliveries was a print of the source code. We actually thought about it. I think for pure luck. So we made proper indentation in the code. So that there would be indentations of the code on the printout. But I mean, it doesn't really make any fucking difference when you're looking at a punch card, because you got this stack of cards. But one of the guys, he didn't do that. And then I think it actually was him who at one class asked if it would affect the view of the teacher on that piece of source code if it wasn't indented. And the teacher said flat out, you won't pass if there's no indentation. So he had an extra little task of making a program that could read in his source code and use that as an input file and make indentation and print it out again. But that's also, I mean, readable source code, whether you use uppercase, lowercase, camel case, or whatever. You have a way of writing your code so that you can yourself sort of identify what are you working with a quick glimpse on the code.
Yeah. But are we happy with that conclusion?
Well, I don't know if I'm happy with it, but that's the conclusion we're going to get anyway.
Yeah, it's life as a developer.
Yeah.
Something you have to work with and try to do as a good job as possible. Yeah, well then.
That should be a starting point anyway, yeah.
Yeah.
Okay.
Yep. See you next week then.
Indeed.
Yeah. Bye.